version of Redis. I'll share on more later what's the difference between these two. So what is Redis? Redis is basically it stands for Remote Dictionary Server. It's more than 10 years. Today it's open source. There's a core community managing it. Previously it was by this guy called Salta or something. So in international market, right, most of the customers using it are usually for caching. But in China, a lot of people use it for a lot more advanced purpose, like queuing systems. They use it as an actual database itself. But in international, most of the time, right, we see customers using it as a caching layer. Within it, it supports different data structure, list, set, hash tables. I'll go through in detail later, how you can use this different data structure and what it can be used for. Today, if you install Redis on your ECS instance, right, it's very easy to get it done. Just install the binary, start it, and then you're good to go. But the problem is when you want to do things like the configuration of data persistency, or you want to configure high availability, right? It's a bit tricky. I'll go on why later. So there are two types of Redis persistent because Redis is an in-memory key value database. So the problem with in-memory is that when the data is not in memory, right, you can't actually use it. It's not like a MySQL. When in MySQL or any database, right, even the data is not in memory, you can still query it, you can still use it. Basically what it does, it goes to the disk, fetch the memory, put it into the buffer cache, and then you can use it. But in Redis, right, before it starts to service any request, it has to load the data into the memory first. Very similar to how SAP HANA works. I think today SAP HANA is configurable. So there are two methods of ensuring that your data is not lost entirely when you shut down the instance. Number one is RDB. I don't know what it stands for, but basically it's a snapshot process. How it works is that it will fork a new child process, then it will write to a temporary file, and then once it's done, right, it will do an atomic swap at the system level. So we call this method called a copy on write. It's configurable. You can configure, say, in this configuration, you can say that for every 60 seconds, right, for the last minute, if I have more than 100 key changes, I will do a RDB snapshot. That's how it works. The problem with RDB is that whenever you fork a new process and you write to a temporary RDB file, right, for large database or database with a lot of traffic, right, it's very prone to jitters. And it's common for Redis to stop working for a second, right, for that kind of workload. So in our ApsaraDB for Redis, right, we actually don't use RDB. We only use this thing called the AOF. It's an append-only log. You can think of this as your bin log or WAL file in MySQL or in Postgres. It's a log file that consists of all the changes that's happening to the Redis database. So there are a few fsync policies that you can configure. You can configure no fsync. Basically, it doesn't flush with this. It just let the operating system to do its work. The other one is you can do fsync every second, or you can do it at every query. So these are configurable. By default, right, it's fsync per second. The performance is so by default, it's fsync per second. So the performance of this, right, is relatively good. AOF file, basically you set a size to it. So whenever it writes to full, right, then you will rewrite, you will do a copy on write as well. You will fork it, write to a temporary file, then automatically swap it with the current AOF. So it rewrites in when it gets to that size. So what Redis in ApsaraDB is that this AOF file, right, it's not, it doesn't get rewrite. It becomes like a redo log. So it will create multiple AOF files. So it's not like you write finish already, then you swap, right? So the original AOF file get replaced. That is in open source Redis. But in our version of Redis, right, or in ApsaraDB Redis, not even enterprise version, the normal version, this AOF file, right, is actually like a redo log. So when you write to it, right, you will create a new file. When it's full, you will write to a new file. The original one isn't replaced. The original file is still kept there. So what is the benefit of this? The benefit of this is that you can do point-in-time recovery based on your AOF retention period. So think of this as like MySQL bin log. That's how we can do point-in-time recovery for Redis today in our ApsaraDB Redis. So if you go to the official Redis documentation, right, it will tell you to use both for persistence method. But in ApsaraDB Redis, right, we only uses AOF because, right, our AOF is not overwritten. It's an incremental AOF. So there's no need to use both. But if customer run on ECS, right, then they probably should have both. But having RDB enabled, right, you will have latency spike when it's doing the fork itself. Yeah, this is how, so Redis can do replication, master slave. So this is how it works. By default, it uses an async replication. You can do sync replication if you run the command wait. So what it means that you wait until it syncs to the secondary, then it blocks on the writer side before it returns. But by default, it uses async replication. So to set up replication is for Redis, right? It's very easy. It's basically just a configuration file, then you start it. So this is how the process, the diagram on the right, it shows how a full sync works. The slave will send the request to the master, ask for a sync. Then after that, right, the master itself will do a background save. Basically, it's trying to create the RDB file. Once it's done, you will transfer the RDB file to the slave, load it into memory. Then while whatever commands that is being written, right, when this BG save is running, it will be buffered. And once it's done, it will send the buffer back to the slave. It is a very simple diagram. Basically, it uses a sync, BG save, transfer the RDB file over. So it's always recommended, so you can have a configuration of different configuration between the master and slave. The persistence, right, you can have RDB disable here, then RDB enable here. You can have AOF enable here and not here. So it's flexible. But what this is recommended by the official site. The official site always recommend you to have the RDB enable on the master. The reason is this: if let's say, right, your master crashed or restarted, and there's no persistent. So when the master shuts down and the master go back up, right, the slave would ask for the sync, right? If you ask for the sync and your master is empty, then the master, all the empty data on the master will be synced back to the slave. Then you got an empty slave. I mean, you are screwed. So the idea is always to have a persistent enabled in the master, so you don't wipe out the entire cluster. This is for Redis high availability. It's a bit dry. I will try to share it in a more interactive way. So Redis, right, uses this thing called Sentinel to enable high availability. Sentinel, what it does, it will do, it's basically an additional process that you run alongside with Redis. It's not built in within the same Redis process. It's a separate process. So it's by default, when you install Redis, right, you will install this binary. So you just need to start it. It's a gossip-based consensus, meaning, right, it's not using like RAF or Paxos to do it. Basically, if one Sentinel detects that the master is down, it will gossip with the other instance and say that, hey, I think the master is down. Can you confirm that the master is down? So there is no strict consensus algorithm to confirm that the master is down. It's a gossip base, and gossip base is actually not a very what's the right word? A very robust or mature way of trying to determine whether the master is down or not. Also, right, for Sentinel, it's always good to deploy a minimum of 3 instances because, right, for the failover to happen, you need a quorum. So if you want to determine that the master is down, 2 of the Sentinel needs to agree at least. So in the idea of a HA, right, how does Redis determine that the master is down? So there is this concept of subjectively down or objectively down, S down or O down. S down happens when a Sentinel detects that the master is down. So only one out of 3 detects that the master is down. So the master is considered subjectively down. But subjectively down doesn't mean that it will trigger a failover. You need a objectively down. You need an O down to trigger it. O down happens when a quorum of Sentinel agreed that the master is down. So you need O down to trigger the failover. Then the replication selection, which one to be the new master, right, is based on the updated data, meaning the disconnection time, the priority. And if both are the same, right, then they will check who has the latest data. The run ID is basically a pseudo number, it's a random number. If all 3, or if the other 2 nodes are exactly the same, then they will just take the run ID of this, which doesn't mean anything besides it's a random pseudo number. Then once the new master becomes the takes place as the leader, right? Then the configuration are broadcast within the channel. Then the other nodes, the Sentinel will look at it, and after that, you update its own configuration. For example, in the diagram on the right, we have M1, M2, and M3. So let's say, right, M1 is the master. And M1, it's there's a network partition. M1 is out of the cluster. So Sentinel-1, S1 is along with the M1, right? So S1 thinks that M1 is still alive. But M2 detects that it can't talk to M1. Sorry, S1 can't talk to M1 at all. So it will write in the configuration that, okay, M1 is down. Then during the gossip, because it's always gossiping about the configurations and everything, right? So when it communicates gossip, when it sends the configuration over to M3, it will tell it that, hey, I think M1 is down. What do you think? Then M3 will say that, oh yeah, I think M1 is down also. Then after that, the Sentinel itself will promote M2 or M3 to become the master. In this example, right, M1 is partitioned out, right? But if let's say the client is still talking to M1, you have a problem that the client thinks that M1 is still the master. M1 thinks that M1 is still the master, but the cluster itself, everybody else know that M1 is down. Then you have a split brain problem, right? So one of the configuration you can use in the Redis configuration is you set this thing, minimum replicas to write, change this to 1. This means that, right, for any write to be successful, right, it needs to write to at least 1 replica. So in this example, if M1 is the minority node out of the cluster, right, and M1 has this replica set to 1, it cannot, once it write to this M1, right, it cannot replicate the data to M2, M3. So the data is not written. So you don't get a dirty write. The client also cannot write to it. So the client knows that this M1 is already down. So it can't write to anything. So at least you don't get dirty writes kind of situation. So this is, if you want to prevent this, then you should set this to 1. But in ApsaraDB, we won't have this problem. So the gossiping, right? This gossip-based consensus algorithm, right? It's like Sentinel will send ping to the Redis master, then the Redis master will return pong, or whether is it loading or whether is it the down. So it sends to all. So ping pong, ping pong. So this is part of the original Redis protocol. This means that if your Redis master is super busy, 100% CPU utilized, and it can't respond to the pong in time, it will be down. It will be deemed as down as well. So let me say that again. If your Redis master is very busy, is processing all the resources, and your Sentinel send a ping to the master cannot respond in time. The Sentinel will think that the master is down. So it is common in a high volume environment that you will have false positive failover. Your master very busy, then it will trigger a failover. Very common, because it uses the same Redis protocol to determine whether a master is down or not. So it's pretty shit. Sentinel is pretty shit. Okay, next is the Redis Serializable. We call it RESP. It's a protocol itself. Basically, this, you can think of this as a HTTP 1.1 kind of message protocol. There is no message ID tagged to it. Basically, you request something, then they just respond. They don't care. They won't respond based on your request ID. There's no request ID concept in that. So that is why a lot of client-side connection puller, right, add this wrapper around to map the request ID and the response ID. So without that, right, Redis can only use this thing, what we call the run to completion. So basically what it means is that when you set, for example, when you communicate to Redis, right, you do a set a key and then the value to VA, right? This is what is sent to the Redis. You can actually telnet to Redis and run this, right? It will respond. Because of this, this protocol itself, Redis actually doesn't scale up when it hits above 10,000 connections. So in this example, right, on the left, right, on this axis is the response time. So the lower the better. On the down, the y-axis, that is the connection count. You can see that at the connection at 10,000, right, the response, the P99 latency actually hits more than 2 milliseconds. For Redis, 2 milliseconds is a lot. For database, it's okay, but for Redis, 2 milliseconds is quite a lot. Then you can also see the operations per second. When it hits 10,000, right, the number of operation per second actually goes down quite a bit. So the default Redis protocol actually doesn't really scale very well in terms of connection count. Okay, so now I'm going to talk about some of the issues with like the open source, the community version of Redis. So you can also shard the Redis to use a Redis cluster. So in that sense, right, every shard is still single threaded. So you scale, but you don't really scale that much. So you still your data is still sharded across multiple different servers, but within the single server, you are still single threaded. So this is the problem with open source Redis today, before version 6. A sharded cluster means that you spread the data from one single server into multiple servers. So let's say, for example, I'm sharding based on UID, right? Then I will have maybe my first shard will have maybe UID 1 to 35. Second will be 36 to 80. Then the third will be 81 to 100. So in that sense, you scale because your data is on different places, right? But let's say on the last shard server, I'm handling 80 to 100. This 80 to 100 is still single-threaded, but it's single-threaded on individual shard. Later, I'll talk about the multi-threaded in version 6. But this is basically, when you scale from a Redis HA to a Redis cluster, right, you are still getting single-threaded, but in Redis cluster, you have single-threaded in each of the shard. So you are pushing the problem further away, but yeah. Then this is another problem for Redis. It's actually linked back to the single-threaded processing, because if let's say one of your client, right, takes a very long time, and your thread is processing this client request, right, it will actually block up the rest of the request that's coming in. So when the query happens, right, let's say you have a key that is like up to 512 meg. So the return is very slow, right? All the rest of the queries that's coming in, you'll be queued behind. The connection is not released back to the client, right? So the client will take a new connection, and then you will slowly, your connection count will go higher and higher. So for those Redis data structure that is not designed properly, you will see a lot of this kind of problem. This problem is actually just something that is derived from single-threaded. If it's multi-threaded, then it's a lot. Then the chance of getting this error will be much lesser. This is talking about the problems with the native Redis cluster from the official Redis lab. So the communication between the nodes are all via gossip. I don't know why, but they like gossip. Maybe they are old aunties and uncles that is designing this. To deploy a native Redis cluster, you need at least 3 nodes for quorum. Data exchange between them, right, are eventual consistent. So there's no strict consistency like RAF or Paxos that's handled. On the SDK side, right, you need an SDK that is supported, just now I was saying it. Then some of the Redis commands are not supported. This line, right, this is common. When you move from a single HA to a Redis cluster, right, some of the commands are not supported, be it for proxy or native cluster. And the experience is highly dependent on SDK maturity. So most of the time, you want something that is highly supported from the official Redis team itself. When the node is started, right, the SDK will actually get a fixed VIP. From the fixed VIP, right, it will identify the rest of the VIP that is tied down to each of the individual nodes. This is how it gets the rest of the VIP at the node VIP, the shard VIP itself. So SDK gets the fixed VIP, the cluster VIP. From the cluster VIP, it will get the rest of the VIP. This is Tair. This is a marketing slide. It's saying that our Redis is 3 times. One thing that you want to note is that we are quite unique in this. Today you can spin up a single node, then you can change it to a HA, then you can change it to a cluster. This can be done within the configuration console. You don't have to spin up a new cluster and then migrate the data over. Today, all of this can be done within the console. There's minimal downtime, disconnections only. Yeah, so these are some of the enterprise Redis feature. Multi-threaded is one. The support up to 30,000 connection. I will share, these are just some of the marketing things. I will share on how we do this. Then the replication, the AOF is actually converted to a bin log. Instead of rewriting the original one, it creates a new one. Then this is the hardware. Basically, we use the latest hardware from Intel. So usually you have your SSD, right? SSD is non-volatile, right? Then you have RAM that's volatile. Then today Intel come out with this that is called the non-volatile memory. I think it's called AEP. Yeah. So today we have this as well, non-volatile memory called AEP. Then there's also for data structure, right? We actually have some quite cool data structure. Later I will share more later. All these data structure are created because of Alibaba Group internal requirement. Then today you can also deploy a multi-region active deployment in Redis. Okay, so this is something that you can be proud of. Today, one of our colleague called Salta, right? It's actually part of the Redis core team, along with AWS, unfortunately, but GCP Azure is not inside. So this guy, right, is actually contributing to the Redis 6 source code. I don't know his Chinese name, but this guy is in the Redis core team today. So it's part of the. So the core team only got 5 people, and we are one of it. Then these are some of the features. These are marketing stuff. I probably won't touch on it. Is there anything that I want to touch? Nothing much. One cool thing is that you can do point-in-time recovery today within our Apsara Redis. I won't touch on this. These are all like marketing stuff. Okay, this is so in Redis 6, right, there's actually multi-threaded. So remember last time officially they say that multi-threaded not required because CPU is not the bottleneck. But in Redis 6, right, they actually started this multi-threaded. This is our version of multi-threaded. We split into worker thread and IO thread. IO thread is basically in charge of writing to the disk. Worker thread is the one that's processing the client request. So what happens is you have the worker threads getting the request from the client side, and then you will throw whenever you need to write to disk, right, or to AOF, or need to interact with the operating layer, right, you will throw the request out to the IO thread, let it process. So compatible with community version. Apparently, I don't know how, maybe later if you are curious, we can get the core team to explain. It has better scalability for a single key as well, for hotspot data. So this feature, this multi-threaded processing is only available in the enterprise edition. Then this is a performance benchmark. So the benchmark numbers are irrelevant. What you just need to know is that for sure, right, our Tair version will definitely be more performant than the community version. Whether it's up to 3 times, right, it depends on the workload itself. These are all a bit of marketing. I'm trying to skip to the proper ones. Then today with Tair, right, you can also do a globally distributed cache, a bit similar to PolarDB Global Database Network. So you can build cache in a different region. Writing data locally, then the sync, right, will be eventually consistent. But this is only with the enterprise version of Redis. Okay, so I'm just talking about features now. Later I'll go into some of the use case. Then the other thing that we can do today, it's point-in-time recovery. If I'm not wrong, this one is supported for our ApsaraDB Redis as well. So how this is implemented, right? It actually uses the AOF file. So remember the open source version of Redis, right? If you install on ECS, the AOF file will be overwritten when the size is big. When it reaches the maximum limit, then it will be overwritten. So let's say if it's 1 gig, right? Once it reaches 1 gig, then all the data will be flushed, and then you write to a new one. So for that implementation, you can't do a point-in-time recovery. But in our AOF, right, it's actually a new AOF file that's being created. The original one is kept. So it's like works like bin log. That is how we can implement the point-in-time recovery. So basically, you recover from your backup, then after that, you roll forward with the AOF file. So you can do the point-in-time recovery. But for international customers, if they are using Redis as a cache, right, then there's not a lot of point in doing this point-in-time recovery. But if the customer is using this as like a in-memory database itself, then this one will be quite an interesting use case. So this is using this feature called the Hotkey adaptive redistribution. This is only available in second quarter of this year. So I'm talking about after June. Basically, how it works is that there is a third-party system that analyzes the hotkey. Then based on the hotkey, let's say you have a user ID 2 that is very hot. So it will rehash those data to split the user ID 2 into maybe 2_1 onto different keys. Basically, it's a third-party system that monitor it, rehash the data so that you remove the hot spot. So this one, I think, was deployed in Double 11 last year. It's not online yet, so I don't have the exact details, but this is something coming up soon. So one of the common issue with customer deployment is that if they have a user ID hash, right, then maybe they got a customer that is, I don't know. So this is one of the ways that they can use to detect the hotkey and then rehash it. Yeah. Okay, this is marketing stuff. But basically in a storage, right, there's actually 3 or 4 different types of storage. You have your cold disk that is spinning RAS or spinning disk, your hard drive. Then you have SSD. And then you have your memory. Memory is the hottest. And then today, right, there is this thing called the persistent memory. Basically, it is almost as fast as your memory, but it is non-volatile. So today, it's not released yet, I think. But in the future, we will have this thing called the persistent memory. So you don't even have to store data in SSD. Everything can be in memory itself. Then these are some of the features. I won't go through into it. Basically, it's saying what are the different Tair version with different types. We will reorganize this again and then release it for international. But there are basically 3 versions. One is performance enhancement, meaning you want to use it for like the fastest performance. And then you have your persistent memory, and then you have your capacity storage. I won't go through into this. These are, you can take a look later. Okay, advanced data structure. This is something very, very cool. So Tair or Redis is one of our strongest products. So the reason is because we use it internally, and because of the requirements driven by internal business group, right? We have came up with advanced data structure. Maybe I should go through the, okay, I'll go through the normal data structure first. Then you can check the difference. So typically in Redis, there's this thing called the string. It's the most basic one. You can use it to store image or any binary up to 512 meg for a single key. So you basically set whatever, then you get whatever. You can also store numbers inside. If you store numbers inside, you can do atomic counters like increment or decrement. So this is very common if you want to store user session details, session cookies. You want to do queues, you can use the string. Not very impressive, but it is what it is. This for string, right, it's an O1 complexity. So regardless of your key size, right, whenever you do this, it doesn't care about how many strings you have. It's always the same performance. Then we have list. List is basically a list of strings. These are all very developer kind of language. Then it's sorted by the inserted order. The longer your list, the slower the access will be. It's an ON complexity. You can have duplicated inside, duplicated values or items inside. So you can use it. You can use the, okay, there's R push and L push, right? So L push means you insert from the left. R push means you insert from the right. So from this behavior, right, you can actually implement a queue or a stack on top of it. Queue is first in, first out, right? Stack is last in, first out. Yeah. So you can use it to implement this kind of thing. So with this 2 data structure, right, you can actually implement things like RSS feed or Facebook feeds or leaders board. But leaders board not so friendly. I will share one more data structure that is very friendly with leaders board. Sorted sets. So sets are like unique. You cannot have duplicates, right? So it's actually a key. It's actually a key value. Meaning, so in this example, I have a sorted set that is called hackers. Then I have another key that is 1940 and then LNK. So you have a P key, S key, and value. No, sorry, it's a P key, S key, LNK is the S key, and then the value is 1940. 1940 is actually the scoring. You can do scores. So it's sorted by the score, not by the element. So it's not sorted by your Alan or Sophie or Alan Turing. No, it's sorted by this 1940, 1953 or whatever. What it does is that you can actually use this to implement leaders board, like who is the top players, who is your top in your games, or who is the, if you do it on core, for example, if you what's the Stack Overflow. Stack Overflow, you have your voted most appropriate answer, right? They uses the sorted sets to do this. So once you add all this in, you can do a range of hackers. This is reverse ascending order based on the score. Then you can get this back. This is ON as well. Then you have your hash. Hash is the most common used one because hash is very easy to implement. Same thing, hash is also key, ASCII, and value type. You can have you can store a lot of shit inside hash. You can have a primary key. Do I have an example here? Yeah, I have an example here. So you can have your P key is username. Then you have your secondary key is and this guy, and then you can have whatever key value at the rest, your birthday or whatever. Then you can get the username. Then you get this one. If you get the birthday, then you get this one. You can get everything as well. So it's the most commonly used because you can store so many things inside. But hash data structure has a lot of caveats to it. So sometimes customers do use the wrong P key. Like they use one big ass P key to store everything. Then it's going to be slow. Then you have an issue with hotkeys and things like that. So the best way, right, is to use hash to store your attributes, like user ID as a P key, and then you store the attributes as maybe as a shopping cart catalog. Or if you want to do products, for example, in the Taobao, right, we use product as a P key. Then you can store the attributes as for each of the key. Then you can even count the product items as well. Yeah. The problem with hash is also that if you don't design your hash properly, you're going to have a very large key. Then you will have a data skew problem, where because it's sharded based on key, right? It's not by the size of the key. So you might have a particular shard that has a lot of data inside. If one of your particular key store too much shit inside. Yeah. This is a very common use case in international market. Everybody use the Redis as a cache. So these are for cache, right? This cache method, right? Whether is it write back or whether you use it for write cache or read cache, right? This thing is common for even for operating system level. If you're familiar with SAN storage, right? SAN storage also got cache, so it works like it as well. Then there's two types of cache. One is you basically application side cache, and then you use the Redis as a common cache. This is one of the common deployment method. The other one is you just use Redis directly as a cache. So you have read cache and write cache. So read is like you read the data, if the data is inside, right, you return. If the data is not inside, you go to the database and get it. A lot of customers like to use this. So it's for like caching your database. So not every request hits the database directly. The other one is you use Redis as a write cache. When you write to it, you delete the existing cache, then you write to a data source. Talk about all this. Any questions on the common data structure so far? I won't touch on the use case. Yeah. So actually, if you go through so far, you'll find that Redis is actually a very developer-centric kind of database, because once you set up the HA and the design itself, right, the rest of it is actually taken on, the rest of the work is actually taken on by the developer. Okay, I'll touch on the Tair advanced data structure. This is something super duper cool. I was quite impressed when I saw it. So these are all the additional data structure that was created just for Alibaba Group internal usage. And these are only available to our enterprise edition. So we have quite a few. I will only touch on for a few items. So we have this data structure called CAS or CAD. CAS stands for compare and swap. So if you are familiar with C programming language, right, the hardest thing is that when you have a particular item and there's concurrency, a lot of client trying to access to this object, right, you have a problem with concurrency. And native Redis data structure doesn't allow you to handle it properly. You need to do workarounds to it. Whereas if you use our Tair, right, we have this CAS data structure, right? basically you can actually lock a particular key. You can lock it, unlock it. Whereas if you use the original Redis data structure, right, you have to check whether has it been changed. If haven't changed, then I can change it. So you need to do workarounds to handle concurrency problem on a particular key. Whereas if you use the CAS data structure, right, you can actually do a lock on the key itself. So what is this used for? If you use Redis to store items for sale, for example, Lazada or any e-commerce website, right? You can actually use this to store your items count. Let's say you want to do decrement or whatever, you can use it. The other one is a Tair string, similar to the original string, but we support atomic structure like compare and swap. So you have a key here, then you can get it, you can set it. So it allows different client to access this, to access the same key. So you can read this Java code. While true means always running. If you try to get a key, then you set it. So it will keep on trying and trying. So you can manage the concurrency on the just by using the Tair string itself. It supports this kind of behavior. You can do an atomic increment, decrement. You can do a compare and swap on the key string, the key value itself. So you don't have to query it, check whether the value is the right value, then you send another request to change it. This is a bit similar to update statement. You update a column if the value equals to this value. So you don't need to do a 2 network requests, just 1 will do. Then this is the Tair GIS data structure. So it's able to support a 2D line kind of GIS. So it's a bit similar to the Postgres GIS extension. So you can store like a user, then the which area it is in, or the location. So for example, this is a school, right? Then you want to store the longitude and latitude of this location. Then you can actually store the home as well. Then you can check whether this user, which location is it, the longitude and the latitude, whether this kid is in the zone itself. So we support this kind of data structure within Redis. This is not doable with in the open source version, there's no such data structure. So instead of your application calculating all these things, wasting CPU cycle on the application side, store the data within Redis, you can do the calculation within the database. No need, you use your existing SDK, because your existing SDK, when you write to it, right, it will be converted to the Redis protocol, right? Our enterprise Redis will be able to, will know that, oh, you are going to use this new data structure. We have a development guide for this new data structure, how to use it, what is the method, what is the function that you can use with this data structure. Yeah, there's actually quite a lot that we have. We have a lot of shit that we also have a data structure that stores time series data. We also have one that stores Bloom filter. It's an implementation of Bloom filter. Then Bloom filter is like a data structure where out of like terabytes of data, then you can detect whether this particular record is in this data or not, without doing the actual comparison. So that there is quite a few, and all this is not we created for fun. These are all requirements driven by Alibaba Group needs. So it's actually proven and used out in the production field today. Yeah. So that's basically, I'll touch on a few only because these are the things that I'm more familiar with. But if you have additional requirement, there's always you can talk to the development team, or we can I can link you up with the right person. Then these are the simple ones. Yeah. Then, but so one of the things that I see, right, the problem is that the international customers, right, always think that, oh, Redis, I just use it to store cache, just cache the data, that's it. That is the most common use case. But in China region, right, the reason why there are so many different data structures is because their customer don't just use it as a cache. They use it for a lot of different types of scenario. That is why they have so many different data structures. So one of the things that we can do as a SA, right, is to drive customer, to teach customer that actually Redis can be used for additional things other than just caching. Because if you think about this, right, if you want to use, because Postgres is very commonly used to store GIS data. And if you just use Redis without the additional data structure, right, it's a very dumb cache. But using PostGIS together with Tair.js, right, you can have a very smart cache inside. And this is used in production. I don't know for which project, but this is one of our customer use case. So yeah, that's about it. I won't touch on the customer use case. This is not recorded. They uses DRDS and Redis as well, but our Redis is proven. That's what I'm trying to say. So actually, we didn't do a lot of Redis sharing because Redis just sells by itself. We don't have a lot of customer complaining about Redis because it's just super fast. There's quite a few customer cases. I won't go through into it. Basically, people use it for caching, either session cache, or just use it as a database cache in front of a relational database. Yeah, that's all for the sharing today.